Welcome back, guys. So this is question 6.25 of the book Probability and Statistics for Engineers and Scientists by Walpole, and the statement of this question is: a process for manufacturing an electronic component yields items of which 1% are defective. Okay, so the 1% items are defective. A quality control plan is to select 100 items, okay, from the process, and if none are defective, the process continues. Use the normal approximation to the binomial to find the probability that the process continues to give the sampling plan described. Okay, so let me first solve part A of my question, and here the given data is the number of items here are 100 and the probability of the defective items is 1%, which is 0.01. okay, as we have been approximating the normal distribution to the binomial one, so therefore the mean here is m equal to np, which is n multiplied by 0.01, which we will get 1, and also the value of the variance is sigma square np 1 minus p. Okay, so putting values here, we will get 100 multiplied by 0.01, okay, and 1 minus 0.01. so from it we will get 0.99. okay, and also the standard deviation from it is, which is the square root of it, or 0.99. that is what that is. Let me calculate it. Square root of 0.99, that is equal to what? That is 0.995. okay, so that is 0.995. okay, so now as we have this probability, we need to find out the probability that the process continues given the sampling plan described. okay, so here we have to use the z distribution, and according to the z distribution we must have some value x which is less than or equal to z, and then we will find out the value for this z. okay, but we don't know this z. What we know here is the probability that if x is what? If x denotes the number of the defective items, so it must be equal to 0. okay, but in order to approximate it into the binomial distribution, we have to take the lowest possible item which we want, which is 0, and the lowest possible item which we will get, that is 1, and we have to divide it over 2. We have to take the average of it, and the average of it will be 0.5. so it will be the probability that x is less than or equal to 0.5. why this? Because we want to transform this into this formula so that we can apply the z distribution here. okay, as we have here this 0.5, what we have to do? We have to distribute it into the z distribution where it will be z1, and then we can apply the z distribution table, which will be phi of z1. okay, so let me call this one as the equation 1. okay, in order to do so, we have to find the value of z1, and the value of z1 is equal to x1 minus mu divided by sigma. okay, we know the value of x1, which is here 0.5. okay, we know here the value of mu, which is 1, and we know the value of sigma, which is 0.995. okay, so let me calculate it. It would be minus 0.5 divided by 0.995. okay, so the value of z1 will be 0.5 divided by 0.995. it will be 0.50. okay, so it would be minus 0.50. so that is the value of z1. now let me put it here, and here putting it, we will get probability that x is less than or equal to minus 0.5, which will be the phi distribution of minus 0.5. okay. So in order to calculate it, let me move towards the distribution table. okay, so that table is here. So minus 0.5, so minus 0.5 is here, this is minus 0.5, and the corresponding value it has is here, that is 0.308. okay, so 0.308, so it will be, sorry, it will be 0.308, and that is what, that is basically the approximated value of the problem what we have, and that is the solution of our part A. In part B, let me solve part B of our question, and let me solve it by this one. And here the probability that the process continues even if the process has gone bad if the frequency of the defective components has shifted to 5% defective. okay, so now the probability has changed to the 5%, and that is 0.05, but the number of items remains the same, those are 100. so therefore the value of mu will change, it will be NP, so 100 multiplied by 0.05, it will be 5, and the value of sigma will be equal to NP 1 minus P square root. okay, so we have to put all these values here. Let me move down somehow. okay, so the sigma here would be, N is 100, that is P is 0.05, these will be multiplied together, and 1 minus 0.05, and then square root of it. okay, so finding it out, the value of sigma would be equal to 2.1795, and that is for this one. okay, now again this problem is the similar one, in which we have to find the probability that x is less than or equal to 0.5, which has to be converted into the x is less than or equal to z2, and then we will find out the value at z2. okay, so actually we need to find out the value of z2, and the value of z2 here is different, and here it is again the x2 minus mu divided by sigma. The value of x2 is, for this part, is 0.5 again. okay, the value of mu is now changed, and that is 5, and the value of sigma is 2.1795, and the output of it will be minus 2.06. okay, so let me take this value, put it here, so we will get the probability that x is less than or equal to minus 2.06. okay, using the similar table we have here, from this table we need to find out minus 2.06, so minus 2.0 is here, and minus 2.0, and for 6 we have this one 06, so it is now 0.0197, 0.0197, and that is what, that is basically the solution of part B of our question. okay, so that's it for today, in which we have seen the solution of question 6.25. if you have any question regarding the solution of this question, you can ask me in the comment box. See you soon.